Hey everyone, welcome back to my channel. Before we get started, don't forget to click the subscribe button if you want more videos about coding interviews. So in this video, we'll be solving the problem LeetCode merge key sorted list. So let's get started. The problem is that they give us an array of key linked lists, and each linked list is sorted in ascending order. And the task here is to merge or group all the linked lists into one sorted linked list and return it. So to solve this problem, we're going to use a technique called divide and conquer. And the idea of this approach is that we'll compare each time the first and the last linked list and then merge them. After that, move into the next pair of the linked lists and compare them until all of them are merged in one sorted linked list. So let's say, for example, we have this input linked list. We're going to start at the first linked list and the last linked list and compare them and then merge them. After that, we'll move to the second linked list and the second last linked list and compare them and merge them again. So once we will have only one linked list left, we're going to recursively return to the first linked list and compare it to the last one again. So we compare the first linked list here and the last linked list here, which have the nodes with the value 2, 4 and 7, and we merge them. Then we compare the last two linked lists left and we merge them, so the result will be one sorted linked list. So the algorithm that we're going to implement in order to solve this problem will start by initializing 3 pointers. The start variable will be at the beginning of the list and the second variable will be at the end of the list. Then we'll have the last pointer g that point to the same object reference as the end variable, so that when we reach the end we can reset it to be the end again. Then we'll loop as long as the end is not equal to 0. So once the end is equal to 0, we'll reset the start to be at the beginning again and g to be the end again. Then we're gonna loop over the list as long as g is bigger than the start. So inside the loop we're going to keep comparing the two current linked lists and merge them until g is bigger than the start. So the advantage that we have in this question is that the linked lists are all sorted. So during the comparison we can use this advantage and compare each node of the two linked lists as we did in the problem, merge two sorted linked lists. If you can solve the problem, make sure you solve it before you solve this one. I already have a video about it. So the algorithm for merging two sorted lists will be that we are going to loop over the two input linked lists and each time compare each current node and merge them into one linked list. So to make things simple, we start by initializing a dummy node that will be the head of the linked list at the start. Then we initialize a pointer that points to the same object reference as the dummy node that will keep adding nodes in the correct order to the merged linked list. Then we are going to loop over the two linked lists. After that, we start comparing the value of the two current nodes that we'll have at hand at each iteration. So if the node from the first linked list is smaller, we add it to the first and move to the next node. If it's bigger, we add the node from the second linked list and move to the second node in the second linked list. And we keep preparing the same process. So there's a case when we'll have two linked lists that don't have the same nodes. So to solve this problem, we are going to keep looping throughout the larger one and add the remaining node to the merged sorted list. And that's it, guys. So the time complexity for the solution is O of n log of k, where n is the sum of number of nodes in all key linked lists. So because we are using a divide and conquer method to merge the key linked lists, each merge operation takes O of n time complexity, where n is the sum of numbers of nodes in the two linked lists being merged. And since we are dividing each time k to 2 at the first level, key divided by 2 at the first level, and key divided by 4 at the second level, and so on, the total number of merge is O of k log of k, or we can say the time complexity of the function is O of n log of k. And the space complexity of the solution is O of 1 because we are using only a constant amount of extra space. That's it, guys. So let's jump at coding the solution. The first thing we need to do is to check if the input list is empty. If true, we return an empty list. Then we initialize 3 pointers, start, end, and g. The start pointer point to the beginning of the list, the end pointer point to the end of the list, and the g pointer point to the same object reference as the end pointer. So after that, we set a while loop that loop as long as the end pointer is not equal to 0. So at each iteration of the outer while loop, the start pointer is reset to 0 and g pointer is set to the same object reference as the end pointer. Then we set an inner while loop that compare and merge pairs of linked lists. So the while loop gonna keep iterating until the g is greater than the start pointer. So inside the inner while loop, we call the function merge two sorted lists to merge the current pair of the linked list. Then we put put it at the start position of the input list. So after each pair of linked lists have been merged, the start pointer is incremented by 1 and the G pointer is decremented by 1. So once the inner while loop terminates, we update the end pointer to be the value of the G pointer and we repeat the same process. So at the end we return the first element of the input list, which is the merged list. So that's it guys. Let's define the merged two sorted links function that's gonna merge the two pairs lists and return one sorted linked list. So we start by initializing a dummy node that will be the head of the merged list. Then we initialize a pointer that points to the same object reference as the dummy node, and this pointer variable will be used to add nodes to the merged list in the correct order. Then we set a while loop that compares the value of the current node and the two input linked lists and merge them into one linked list. So if the value of the current node in the first linked list is smaller than the value of the current node in the second list, the node from the first linked list is added to the merged list first, and the pointer is moved to the next node in the first linked list. Otherwise, if the value of the current node in the second linked list is smaller than the value of the current node in the first linked list, the node from the second linked list is added to the merged list first, and the pointer is moved to the next node in the second linked list. So if there are any remaining nodes in the first linked list, we add them to the merged list, or any remaining node in the second list, we also add them to the merged list. Finally, the function returns the merged sorted linked list. That's it guys, thanks for watching, see you in the next video.